Space has forever fascinated humans with its limitless possibilities and ever-changing structures. However, with JWST's advanced technology, we can now see astonishing details that were impossible to view with the Hubble Space Telescope, and we're finally closer to understanding the mysteries of the galaxies. The James Webb Space Telescope, or JWST, is the largest optical telescope in space that's equipped with high-resolution and high-sensitivity instruments. Thanks to its advanced technology, it enables us to view space objects that are too distant, old, or faint for the Hubble Space Telescope. With the JWST, our vision now extends to astonishing cosmic distances, completely redefining the oldest galaxies humanity has ever witnessed. One example is the CEERS 93316, a galaxy 35 billion light-years from Earth. Recent observations with the JWST show this galaxy as a red blob, and researchers believe it might be the farthest galaxy ever spotted. Here's what we know about the CEERS 93316. The galaxy first appeared around 235 million years after the Big Bang, an event that created the universe's first stars and galaxies 13.8 billion years ago. After the Big Bang, the universe entered the Dark Ages, a time before any stars had been born. But the observation of the CEERS 93316 opens up new possibilities, where scientists may be able to witness the universe much further back, even all the way back to observing the Big Bang itself. The data received from JWST also set a new redshift record of Z equals 16.7. Redshift is part of what we call the Doppler effect, and it's used to measure distances in the universe. What makes the findings of CEERS 93316 so intriguing is that, in principle, the JWST can detect galaxies at redshifts greater than 20 or less than 200 million years after the Big Bang. Hence the fact that the telescope could detect a galaxy at a redshift of 16.7 is absolutely amazing. Can you imagine what other secrets the JWST could unlock in the next few years? Here's another impossible to get image the JWST delivered: Cassiopeia A. Around 350 years ago, Cassiopeia A burst into existence after a star 5 times the size of the Sun exploded. At the time, understanding why the star spewed its innards outwards was only limited to theory, but recent images captured by the Webb have allowed scientists a chance to decipher the composition of the parent star and its catastrophic explosion. Danny Miloslavovich, a principal investigator of the Webb program, believes Cass A is an opportunity to look at the debris field of an exploded star and run a kind of stellar autopsy to understand what type of star was there beforehand and how the star exploded. Cass A is around 11,000 light-years from Earth and can be seen surrounded by a layer of reddish-orange dust from 2 sides. This is actually where materials expelling from the star during the supernova event are crashing into nearby dust and gas. Astronomers believe the glowing pink strands represent remnants of the parent star, comprising elements such as oxygen, argon, and neon, along with other elements researchers are still trying to identify. The super detailed images of Cassiopeia A have provided researchers insight into a mechanism crucial for the cosmos: the creation of planets through the dust. Are you wondering what insights cosmic dust could provide to revolutionize our knowledge of cosmology and galaxy evolution? The answer might catch you off guard. If we can understand the process of exploding stars, we'll be in a better position to comprehend the creation of our own planet. Another exciting image revealed by the powerful space telescope is Able 2744, 3 clusters of galaxies coming closer to form a megacluster. The region is nicknamed Pandora's Cluster. Interestingly, in Greek mythology, when Pandora opened a container to satisfy her curiosity, she unleashed evils and hardships that now plague our world. We hope the James Webb Space Telescope didn't do just that as it zoomed in on Pandora's cluster. Researchers have only been able to study the central core of this region previously with the help of the Hubble Space Telescope, which means there are several details still unknown to us. However, the recent images captured through the Webb have allowed us to view a deep field image of Pandora's cluster, located some 3.5 billion light-years away. The astounding details of the image will blow your mind. If you look at the image closely, you can see a prominent bright star with diffraction spikes created by the telescope. Around the star are other bright sources of white light, enveloped in a hazy glow, indicating distant galaxies of the cluster. The final image of Pandora's cluster has been achieved by stitching together 4 Webb snapshots into a single panoramic view, displaying almost 50,000 sources of near-infrared light. A lead researcher on the project conceded that the first images of Pandora's cluster from the telescope left him a little starstruck. The immense amount of details in the foreground cluster was something no one had imagined possible. Another researcher on the same project commented that the first time he viewed the images, it felt as if he was looking at a galaxy simulation, and he had to remind himself that the data was actually real. Do you think Pandora's cluster, as imaged by Webb, looks too beautiful to be real? You can see so many distant lensed galaxies that it's easy to lose yourself in the image and its endless possibilities. There's no doubt that the JWST exceeded everyone's expectations. Another astounding James Webb Space Telescope image released by NASA is the galactic hourglass of fire known as the Dark Cloud Nebula L1527. You wouldn't believe the details the powerful telescope has captured. Taken by JWST's near-infrared camera, the image shows invisible wavelengths of light revealed and translated into colors of visible light to show the very initial phase of the formation of a new star. The new protostar, which is around 460 light-years away, is hidden within the neck of the hourglass-shaped cloud, and light from the star can be seen above and below it, illuminating the cavities within the surrounding dust and gas. The most prevalent features of the region are blue and orange-colored clouds. These colors can be seen due to the layers of dust between the clouds and the telescope. Areas colored blue are where the dust is thinnest, and as the layer of dust thickens, less blue light can pass through, creating areas of orange clouds. You'd be surprised to learn all this chaos is for a 100,000-year-old protostar. Do you think the star is old or a relatively young body? L1527 is considered a Class 0 protostar, since it is at the most initial phase of star formation. Protostars like L1527 have a long way to go before they transform into full-fledged stars. For a long time, they'll remain nestled in a dark cloud of dust and gas, unable to generate their own energy through nuclear hydrogen fusion. The image captured through JWST shows L1527 drawing dense clouds of gas and dust towards its center, taking it a step closer to achieving a stable nuclear fusion at its core. Let's now look at our own galaxy, where the planet Neptune has mystified researchers for many years. Since the planet is a great distance from Earth, it's one of the least explored planets in our solar system. Can you guess which other planet is a mystery to researchers? Its fraternal twin Uranus. The only details we have about Neptune are from the brief flyby of Voyager 2 in 1989, which means most studies of the Neptune system are in the realm of scientific discovery. Data from the Voyager 2 revealed the planet has a dynamic atmosphere and a complex ring system. But you'd be shocked to see the details the Webb has allowed us to view about this intriguing planet. These new images show the planet's 14 known moons, along with a spectacular system of rings. The pictures show Neptune's thin rings and never-before-seen dust bands in infrared spectrum. Since the rings are more reflective in the infrared, you can see them clearly. We always picture Neptune as a blue-colored planet. That's because of the images taken by the Hubble telescope, where the planet can be seen with a smurf-like blue hue. This color is caused by methane in the atmosphere. However, in the images taken by the JWST, Neptune doesn't appear as blue because methane absorbs infrared light, and the areas not covered by bright, high-altitude clouds appear dark in the pictures. You can also see the methane ice clouds in Webb's images as glowing streaks and spots, since those areas reflect sunlight. Another prominent feature is the bright star shining above Neptune, but in reality, it's not a star, but the planet's largest moon, Triton. Since Triton is covered by a light-reflecting frozen layer of nitrogen, it appears to be as bright as a star. Thank you for voyaging with us through galaxies. We hope you enjoyed the ride. Remember to hit the like button, subscribe to our channel, and press the notification bell for more exciting content. Until next time, keep exploring.